So here we're going to talk about graphing sine and cosine functions. And before we talk about that, I want us to learn two vocabulary terms, and that's amplitude, and the period. So the amplitude of a graph is your vertical distance from the median to the max, or a median to a min. So if I drew out a graph, and the graph looked like this, to measure my amplitude, I would go from the median to a max point. So in this case, your median is your middle point. So this would be my median, and median to my max. So from here to here, that would be my amplitude. But I could also measure from my median to a minimum, and that's also my amplitude. So I can either measure from median to max, or I can measure from median to min. Okay, and that's my amplitude. So the second thing we're going to talk about is the period. So the period is the horizontal distance. It's how long it takes to return to the original starting position. So if I drew out another graph and it looked something like this, I need to pick a point, any point on my graph. So let's say I pick right here. This is a max point. So I have to pick another point on my graph where it hits a max, so the next max point. So in this case, it's going to be right over here. So that's one full period. It's the horizontal distance from one max to another max. You could also measure from one minimum point to another minimum point. So if we were to write this out, we would say that the period is your horizontal distance, and you can either measure it from max to max, or you could go from min to min, or you could also measure it from median to median to median. But if you were going to measure from a median point, so let's say this point, you can't just stop here, go from here to here and call that your period. You have to go 3 median points. So you'd have to go 1 median, 2 median, and 3 median. And then from there to there, that would be your entire period. The easy way to go is max to max or min to min. So now that we know that, we're going to jump into graphing a sine function. So in this case, I have the basic sine function, which is y equals sine theta over this given interval. So the first thing I'm going to do is create a table of values. And I know I'm going to have my x-axis and my y-axis. But in this case, on my x-axis, it's theta values. So I have to pick angle values. So I'm going to look at my unit circle and say, okay, what are some points I know on my unit circle over this interval that I can include in my table of values? So the first thing I'm going to do is include negative 2 pi. I'm going to write out negative 2 pi. My next point is going to be at 270 degrees, which is negative 3 pi over 2. Then I'm going to have 180 degrees, which is negative pi. Then I'm going to have 90 degrees, which is pi over 2. It's negative because I'm going clockwise, because in my restriction, I have to go clockwise 1 full rotation, and I have to go counterclockwise 1 full rotation. So after 90 degrees, I'm going to have 0, and now I'm going counterclockwise. So I'm going to have pi over 2, pi, 3 pi over 2, and 2 pi. So now I'm going to think, okay, I'm talking about a sine function, so I'm looking at sine values. So if I were to say at negative 2 pi, what's my sine value? I'm going to look at my unit circle and say, okay, negative 2 pi, that's a clockwise rotation. So I'm starting here and I'm going 1 full rotation and I'm going to end up right back here. So if I end up right back here, what are my coordinates? Well, I know my coordinates are just 1 and 0. Okay, so if I have 1 and 0, which one of these is my sine value? I know that coordinates are written as cosine and sine, meaning my first number is cosine and my second number is sine. So when I have -1 and 0, my second number is the sine value. So that means my sine value at -2 pi is just 0. Okay, I know that now. What about -3 pi over 2? Well, -3 pi over 2 is 270 degrees clockwise. So I'm going from here to here. And the coordinates here are 0 and 1. And I know my second value is the sine value, which is 1. So I'm going to write at -3 pi over 2, it's 1. At -pi, that's 180 degrees clockwise. So it's this way. Coordinates here, -1 and 0. Well, 0 is my sine value, so 0. At pi over 2, that's 90 degrees clockwise, so that's this way, 0 and -1. So in this case, my sine value is -1. 0 degrees, which is just right here, it's 1 and 0. Those are my coordinates. So my sine value is 0. Now I have pi over 2, and this time I'm going counterclockwise. So counterclockwise, pi over 2, which is 90 degrees, is 0 and 1, so which means my sine value is 1. Remember, your second value of your coordinates is your sine value, because you always go cos theta, sine theta. So whatever that second number is, that's your sine value. So at pi, I'm at -1 and 0. -1 and 0, so my sine value is 0. At 3 pi over 2, I'm at 0 and -1, so my sine value is -1. And then at 2 pi, I'm at 1 and 0, and then that's going to be 0. So now that I have my table of values, the next thing to do is just plot these points and then connect the dots. So that's what I'm going to do on here. So I'm going to create my increments on the x-axis. So I'm going to go pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to do the same thing on this side, but it's just going to be negative. -pi over 2, -pi, -3 pi over 2, and -2 pi. And on the y-axis, I can see I have a maximum point of 1, so I'm going to go 1, and then I have a minimum point of -1. So I'm going to write -1 right there. So now I'm just going to plot each point. So at -2 pi, I'm at 0, I'm at 0. At -3 pi over 2, I'm at 1. At -pi, back at 0 again. -pi over 2, -1, 0 and 0. Pi over 2, 1, pi, 0. 3 pi over 2 is at -1. 2 pi is back at 0 again. So now I'm just going to connect all these dots. This might not look so pretty because I'm not doing it on graphing paper, so the points are a bit inaccurate, but you get the idea. Okay, so now we're going to look at some points on some important points on this graph. The first thing to keep note of is that I was given a restriction. I was given a domain. So I went from -2 pi and I went to +2 pi. And I didn't draw arrows at the end of my graph because this restriction only allowed me to stay within these two numbers. But if I didn't have these restrictions, then I would just continue on this way and continue on this way. Okay. Now the second thing we're going to look at is now we're going to determine what the amplitude is and what the period is, the terms that we learned earlier in this video. So if we recall, the amplitude is just the distance from your median to a max, or it could be from a median to a min. So in this case, let's look at median to a max. So going from your median here is at 0, because this is your middle point, 0. And then your max point is at 1. So in this case, your amplitude is 1. amplitude is 1. Okay, now let's look at your period. So if we remember, we can either go from max to max, we can go from min to min, or we can pick 3 median points. In this case, let's try 3 median points. This is my first median, second median, third median. So from all the way to here, what's my period? Well, I know my period is the horizontal distance, so I'm looking at my x-axis. So if I start at 0 and I end at 2 pi, my distance was 2 pi, meaning my period is equal to 2 pi. Okay, now let's look at another thing, domain. So your domain is the distance, is the entire distance on your x-axis. Okay, let's not look at our restriction for a minute. Let's pretend this graph continues on forever. And remember that domain, you move from this side and you continue on this way. Okay, so for my domain, I can see that this graph will continue on forever because there's arrows. And this is the negative side, so it's going to keep on going forever on the negative side. So it's to negative infinity. And on this side, now if I move this way, it's getting positive and it's staying positive forever. So then it's going to go to positive infinity. But this infinity is not a specific point on my graph. So it's not inclusive on my graph. That's why I'm going to use round brackets instead of square brackets. If I were to use square brackets, it would mean that it's inclusive in my domain, but infinity is not inclusive in a domain. So now I have range. So for my range, that I know that deals with my y-axis, and that deals with going from your lowest point to your highest point. So my lowest point on here is -1, and my highest point is +1. And these are specific points on my graph where my graph hits. So these are inclusive in my range, so I'm going to use square brackets to show that they're inclusive. Okay, now that we have that, now we're going to look at one more thing, and that's the zeros of your function. So the zeros basically mean your x-intercepts. So we're going to look at where the x-intercepts occur on this graph. We can see that the first x-intercept occurs at 0, and then we have another at pi, and then we have another at 2 pi. Okay, now let's see how often these x-intercepts are occurring. So we have one at 0, then we add pi, so we add pi and we get another one at pi. If we add another pi, we get another x-intercept. Okay, so we know that there's an x-intercept happening every pi. So we can't list out every single x-intercept because this graph continues on forever. So what we're going to do is we're going to write a general solution for this graph that's going to include all possible x-intercepts. And we're going to do this by writing theta, because our x-axis deals with theta values. So theta equals, then we're going to list our first x-intercept. We can list any x-intercept, but I like to start with 0 because 0 is easy. So our first x-intercept is at 0, and we know that there's an x-intercept occurring every pi. So if I subtract a pi, I get an x-intercept. I subtract another pi, another x-intercept. Same here, I add a pi, get an x-intercept. Add another pi, get another x-intercept. So it's happening every pi. And I can add however many pi's I want, I'm going to get an x-intercept. So the however many I want to add is an unknown variable, and I'm going to call that my k. So for every pi k, where k is an element of the integers, meaning that my k value could either be negative or it could be positive, because we can either add pi or we can subtract pi however many times we want. So that's going to be my general solution for my zeros or x-intercepts of a basic sine graph. Okay, now do we have any y-intercepts? Yes, we do. We only have a single y-intercept, and that's at 0. Okay, and lastly, do we have any asymptotes? No, we do not. There's no asymptotes. And that's how you graph a basic sine function.